Recently, very important news has emerged about Earth's Pulse, Juno mission and a lot of news. The first news with us says, Tech Today, taking Earth's pulse with NASA satellites. Natural disasters like volcanic eruptions, floods, and tornadoes can dramatically change the surface of Earth to the point where alterations are visible in space. Changes driven by human actions and interventions, such as mining and deforestation, are also visible in satellite imagery. For over 50 years, NASA's Landsat satellites have recorded our planet's changing surface. Now, TerraPulse Inc., a North Potomac, Maryland-based company, applies artificial intelligence to create meaningful maps to help academic institutions, non-governmental organizations, and businesses understand the many impacts of climate change. By combining data from multiple NASA and European satellites, TerraPulse helps businesses make data-driven decisions regarding ecological impacts. That same data helps scientists understand environmental changes and the processes driving them, which can provide practical information to local decision-makers for infrastructure planning and disaster preparedness. Measurements taken from space are still undergoing significant research and development. NASA's Earth Sciences Division funds several remote sensing initiatives to expand our understanding of the impact of land cover change, including a TerraPulse effort using Fitbits to track and assess the health of wild deer and the impacts of their habitat change. NASA's Goddard Space Flight Center in Greenbelt, Maryland, which manages many of the agency's Earth monitoring satellite missions, supports a comprehensive view of our planet. Industries are looking to satellite data to plan for resilience to climate change by monitoring worldwide facilities, identifying manageable risk factors, and more. The second news with us says, NASA's Juno gives aerial views of mountain, lava lake on Io. Imagery from the solar-powered spacecraft provides close-ups of intriguing features on the hellish Jovian moon. Scientists on NASA's Juno mission to Jupiter have transformed data collected during two recent flybys of Io into animations that highlight two of the Jovian moon's most dramatic features: a mountain and an almost glass-smooth lake of cooling lava. Other recent science results from the solar-powered spacecraft include updates on Jupiter's polar cyclones and water abundance. The new findings were announced Wednesday, April 16, by Juno's principal investigator Scott Bolton during a news conference at the European Geophysical Union General Assembly in Vienna. Juno made extremely close flybys of Io in December 2023 and February 2024. Getting within about 1,500 kilometers of the surface, obtaining the first close-up images of the moon's northern latitudes, Bolton said Io is simply littered with volcanoes, and we caught a few of them in action. We also got some great close-ups and other data on a 200-kilometer-long lava lake called Loki Patera. There is amazing detail showing these crazy islands embedded in the middle of a potentially magma lake rimmed with hot lava. There is amazing detail showing these crazy islands embedded in the middle of a potentially magma lake rimmed with hot lava. The specular reflection our instruments recorded of the lake suggests parts of Io's surface are as smooth as glass, reminiscent of volcanically created obsidian glass on Earth. Maps generated with data collected by Juno's microwave radiometer instrument reveal Io not only has a surface that is relatively smooth compared to Jupiter's other Galilean moons, but also has poles that are colder than middle latitudes. Pole position. During Juno's extended mission, the spacecraft flies closer to the North Pole of Jupiter with each pass. This changing orientation allows the MWR instrument to improve its resolution of Jupiter's northern polar cyclones. The data allows multi-wavelength comparisons of the poles, revealing that not all polar cyclones are created equal. Steve Levin, Juno's project scientist at NASA's Jet Propulsion Laboratory in Southern California said, "Perhaps most striking example of this disparity can be found with the central cyclone at Jupiter's North Pole. It is clearly visible in both infrared and visible light images, but its microwave signature is nowhere near as strong as other nearby storms. This tells us that its subsurface structure must be very different from these other cyclones." The MWR team continues to collect more and better microwave data with every orbit, so we anticipate developing a more detailed 3D map of these intriguing polar storms. Jovian water. One of the mission's primary science goals is to collect data that could help scientists better understand Jupiter's water abundance. To do this, the Juno science team isn't hunting for liquid water. Instead, They are looking to quantify the presence of oxygen and hydrogen molecules in Jupiter's atmosphere. An accurate estimate is critical to piecing together the puzzle of our solar system's formation. Jupiter was likely the first planet to form, and it contains most of the gas and dust that wasn't incorporated into the Sun. Water abundance also has important implications for the gas giant's meteorology and internal structure. In 1995, NASA's Galileo probe provided an early dataset on Jupiter's water abundance during the spacecraft's 57-minute descent into the Jovian atmosphere. But the data created more questions than answers, indicating the gas giant's atmosphere was unexpectedly hot and contrary to what computer models had indicated bereft of water. The probe did amazing science, but its data was so far afield from our models of Jupiter's water abundance that we considered whether the location it sampled could be an outlier, but before Juno, we couldn't confirm. Now, with recent results made with MWR data, we have nailed down that the water abundance near Jupiter's equator is roughly 3 to 4 times the solar abundance when compared to hydrogen. This definitively demonstrates that the Galileo probe's entry site was an anomalously dry, desert-like region. The results support the belief that during formation of our solar system, water ice material may have been the source of the heavy element enrichment during the gas giant's formation and evolution. The formation of Jupiter remains puzzling, because Juno results on the core of the gas giant suggest a very low water abundance, a mystery that scientists are still trying to sort out. Data during the remainder of Juno's extended mission may help, both by enabling scientists to compare Jupiter's water abundance near the polar regions to the equatorial region and by shedding additional light on the structure of the planet's dilute core. During Juno's most recent flyby of Io, on April 9, the spacecraft came within about 16,500 kilometers of the Moon's surface. It will execute its 61st flyby of Jupiter on May 12. The next news with us says, 2 NASA sounding rockets launch from Alaska during solar flare. 2 Black Brant 9 sounding rockets launched from Poker Flat Research Range in Fairbanks, Alaska, April 17, 2024, during an M-class solar flare for NASA's Sounding Rocket Solar Flare campaign. The first rocket launched at 2:13 p.m. local Alaska time for the Focusing Optics X-ray solar imager mission that used X-ray vision to observe the Sun during the solar flare event by focusing directly on high-energy X-rays. The second rocket launched at 2:14 p.m. for the High-Resolution Coronal Imager, mission designed to observe a large, active region in the Sun's corona. The rockets reached altitudes up to 271 kilometers and were able to successfully observe the solar flare. The next news with us says, NASA data helps beavers build back streams. Humans aren't the only mammals working to mitigate the effects of climate change in the western United States. People there are also enlisting the aid of nature's most prolific engineers, beavers, using NASA-provided grants. 2 open-source programs from Boise State University in Idaho and Utah State University in Logan are making it possible for ranchers, land trust managers, nonprofits, and others to attract beavers to areas that need their help. The Beaver Restoration Assessment Tool created by Utah State University uses data from satellites built at NASA's Goddard Space Flight Center in Greenbelt, Maryland, to identify areas that need restoration and would benefit from beavers' dam building abilities. The Boise State University Mesic Resource Restoration Monitoring Aid Program, which also uses satellite data, monitors the areas over time. Both efforts are also supported by NASA's Research Opportunities in Space and Earth Science Program and the agency's Applied Sciences Ecological Conservation Program. Once a site is chosen, program staffers and landowners begin to take measures to attract beavers, or the teams may relocate them from other areas. Either way, once on site, these semi-aquatic builders get to work building and maintaining dams to create the ponds. The ponds help to retain water, including runoff from snowmelt and rainstorms, that would otherwise rush through the area, causing erosion and degrading the surrounding ecosystems. Over time, these new ponds raise the water table, support wetlands that attract more wildlife and fish, and restore native plants to the ecosystem. Beaver dams can help ranchers improve water availability on their property, supporting their operations. In addition to being beautiful and supporting the local ecology, these moisture-rich environments can limit wildfire damage with a barrier of healthy vegetation resistant to burning. When human infrastructure is nearby, A built-in leak or other interventions by humans can be added to control the water level, preventing floods that cause property damage. As a restoration site's health improves, NASA satellites use data to monitor those changes and analyze how the beavers benefit the ecosystem in drought-stricken areas. Community leaders can use this information and the living examples of restored sites to build new parks and recreational areas and plan future restoration projects with their furry collaborators. The last news with us says, NASA selects new aircraft-driven studies of Earth and climate change. NASA has selected 6 new airborne missions that include domestic and international studies of fire-induced clouds, Arctic coastal change, air quality, landslide hazards, shrinking glaciers, and emissions from agricultural lands. NASA's suite of airborne missions complement what scientists can see from orbit, measure from the ground, and simulate in computer models. Funded through the agency's Earth Venture program, the missions center around the use of instruments mounted on aircraft to make measurements in finer detail both in spatial resolution and shorter time scales than can be made by many satellites. Competitively selected, the missions provide opportunities to supplement satellite observations and make innovative measurements. Karen Germain, director of NASA's Earth Science Division, said, "These missions will help us interpret what our current satellites are seeing from space and test new ideas and techniques for our upcoming Earth System Observatory. There is also a strong focus on actionable Earth science gathering fundamental observations that have connections to our economy and societal decision-making and information needs." Roughly $120 million has been allotted for the 6 missions, which will deploy at various times from 2026 to 2029. 3 lead investigators were chosen for each mission, with at least one required to be an early career scientist. Full staffing of the science teams and selection of complementary instruments will be completed in the coming months. These changes in the selection process were made to promote diversity, equity, and inclusion in the teams. Barry Leifer, the program manager who led the Earth Venture selection panels at NASA headquarters in Washington, said, "We are constantly looking to foster the growth of the next generation of scientists. This round of missions will put an extra emphasis on bringing new people into mission planning and leadership." The 6 missions include Arctic coastal change. Maria Tsortsia of the City College of New York will lead a project to observe changes in river systems on the north slope of Alaska. Known as Forte, the project will combine optical and radar measurements from planes, helicopters, boats, and drones to measure water flows and chemistry and observe how ecosystems respond to changing climate. The team will collaborate with indigenous communities to sustain observations over time. Clouds created by fire. In the pyrocumulonimbus experiment, David Peterson of the Naval Research Laboratory in Washington will lead a study of pyrocumulonimbus clouds, which form when wildfires burn hot enough to make their own weather. Flying over the western US and Canada, researchers will examine the fire characteristics that produce pyrocumulonimbus, while exploring the mechanisms that lead these clouds to inject smoke into the stratosphere, where it can have climate effects. Urban air pollution. James Crawford of NASA's Langley Research Center in Hampton, Virginia, will lead hemispheric airborne measurements of air quality, a project that capitalizes on the recent launches of NASA's Tempo Pollution Monitoring Satellite Instrument and comparable measurements made by Korean and European satellites, over Mexico City and a U.S. city to be determined. Scientists will investigate areas of poor air quality and test how satellite information can help improve ground-based forecasting and mitigation strategies. Shifting weather, shifting lands. Climate change is leading to more extreme droughts and rainfall events that affect the stability of hillslopes and the soil and rock on them. Led by Alexander Handwerger of NASA's Jet Propulsion Laboratory in Pasadena, California. Landslide Climate Change Experiment will combine airborne measurements with land-based sensors to track the way slopes and landslides are changing as water moves differently across the landscape. Glacier Retreat. John Holt of the University of Arizona will lead Snow for Flow, a project to quantify the retreat of glaciers and ice sheets in ways that can lead to better projections of land ice change. In Alaska, southeastern Greenland, the Canadian Arctic, and Svalbard, the team will use microwave and high-frequency radar sounders to measure snow accumulation, ice melting, and changes in ice thickness and motion. The 6 missions were funded with $120 million. Thank you very much for watching. Goodbye.